Welcome everybody. With a couple of minutes of delay, I would like to welcome you on the workshop on fair monitoring data practices in urban drainage. And this is like part from two initiatives, but I will come to that. The speakers are like me. I give a quick introduction. Then we are happy to have Henrik Dissing from the Water for All project, and Alfredo will Chavarria from Eawag will then present the results we have been working on in the last years. And after that, we would have an open discussion. So the goal would be to share experiences and maybe have a discussion where this could go for our field. And to start, like I'm here, we made this picture, and it's a pretty nice introduction, I see, because like there are two things. The first thing is you see a sewer worker who is bringing data into this fairy tale castle. And if he is running and operating the sewer system, fixing pumps and like unclogging pipes, he has probably not a very good idea what fair data mean. So it's like this findable, accessible, interoperable, and reusable stuff, but he probably is lacking the skills to really do this. If this is not really standardized. And the second stuff is that this picture, as so many now, has been generated with a large language model. And these large language models are a very interesting example because this would not happen if like the language was not standardized and if they didn't have like terabytes or even more to train on, right? So the standardization is key, and then the availability of the data, which makes it possible to develop new services. And why are we meeting today? There are two angles, as I mentioned. The first one is coming from the Co-UDlabs project, which is a European project where urban drainage researchers got together. And we are leading the work package 2 on data harmonization in this initiative. And the second part is like an international working group on data and models of the urban drainage community. We are associated with the Joint Committee on Urban Drainage of the International Water Association. And our goal would be to further research and disseminate knowledge and technology related to the data collection and modeling of urban drainage systems. So what are we looking at? From the Co-UDlabs side, like it's about giving other people access to very specialized machines. And on the left side, you see like lab equipment and laboratory setups, like the Alpha Loop in the Netherlands. And the long-term goal would be to reuse this scientific data. And this is like very much about individual laboratory setups, machines which probably only exist once in the world. The second thing is how do we reuse real-world data, right? And this goes into the direction of this text. Like we have a lot of data sitting around and we develop like innovative services. One thing which has been popular in the recent years was this like combined sewer overflow data from the UK, like where like some NGO put available government data openly into the internet, and that caused quite some changes. The second initiative of our group is that the colleague João Leitão would like to collect flood map data from models to build a data archive so we could develop fast flood models. These are the two angles we're looking at, and like the flood map archive is not yet there. So this is something which we'll be working on, and we are happy to invite collaborations. But basically we have very specialized data from machines on the one side and very data which like every municipality has, maybe which was also collected by some governments. But on a higher level, these government data might or might not be compatible to each other. And with this, I would like to give the word to Henrik. The goal of our exercise today, as I mentioned, is to bring together the experts and share experiences. Like from our point of view, it would be very nice if some of you could collaborate to an interest group to work on a review of current standards, because we have collected standards, but it's probably we need the community to comment on that. And we envision to have a series of online meetings in 2025 to organize this. and then most probably discuss the results with the community at the Urban Drainage Modeling Conference in Innsbruck, which is like organized by members of our Data and Models Working Group. And with this, I hand over to Henrik, who would like to present us on the actions of the Water for All project. Henrik, the floor is yours.
Thank you very much, Jörg. First of all, just a practicality. Will you swap the slides for me?
Yes.
Okay. Yes, as outlined, I'm wearing two caps, both from Water for All and the Danish Environmental Portal. I'll quickly introduce you to what the two structures are. Next, please. The Water for All is a innovation and research partnership. It has 90 partners from around 30 countries, mostly European, but also you can see they're also international. And that is a multi-activity structure, which in a corner of it also looks into data sharing and establishing optimal framework conditions for researchers and innovators in becoming data-driven. Next, please. Next. The Danish Environmental Portal is if you look at the right corner, it's a co-owned structure of government, municipality, and regions, handling all environmental data from these three levels, but also from around 50 other organizations. It covers the entire biosphere terrain area, so it's both not only water, but also biodiversity, soil, nature, even rats. Advantage with that is it means that as all data are publicly free, they are harmonized and immediately available for all interested parties, actually going out to being used by 2,000 organizations. This is quite well prepared for various types of cross-sector and cross-border cooperation. And this also constitutes quite a share of the inspiration for the Water for All white paper. I'll mention a couple of solutions we have made, which is of relevance for you. One is the hydrometry system, which means that all loggers monitoring water flow and levels, but also groundwater close to terrain, goes into the same system. Another feature is a couple of tools we have to mean that all chemical parameters, hereby the measurements of the water quality, they are fully interoperable, as we have something called a parameter list, which makes the exchange between 5 different classification systems. Next. The white paper of Water for All has the overall purpose of building leadership focus on data management. It should sound obvious in the digital time, but thing is, it isn't. Most top leaders, being in EPAs or water using organizations, basically don't have a clue about data management. That's left to the IT people with pizza bars and Cokes and Energizer drinks, and people don't really relate to it. And effect is, data are still fragmented. They are not interoperable. They are difficult to find and access. And that means that we have very nice digitalization examples within certain silos. But as soon as you bring the data sharing element up, we only have, I would say, good examples from the publicly available data. Example giving, Danish Environmental Portal. So the purpose is to create attention. Therefore, the white paper is held in a non-technical language. It does not emphasize talk about standards, etc., but it talks about value potential. It talks about costs related to data washing and lack of interoperability, and it points to some key elements of a water data ecosystem, adhering to the FAIR principles, using the observation and measurement principles, striving for interoperability at the across the three main domains, and aiming at having one generic data model covering the entire water cycle. So not considering marine data for itself, not considering groundwater data for itself, or considering urban drainage for itself. It's all part of the same water cycle, and data should be treated equally. Finally, super important ambition is to make these relevant data. The word relevant is quite important for companies, startups, researchers to actually become data-driven and actually delivering data relevant solutions. We have had this white paper out for circulation within the waterfall network, within the WMO data policy group, within a number of EU units and some other structures, and I'll be happy to share it to you to have a look at it and eventually comment and engage in further discussion about it. But I think we have found something here which can actually create quite an interesting discussion as the foundation for a water data ecosystem and really making data sharing a possibility. Next, please. One recommendation I mentioned was to go for to look into the chemical domain and getting the interoperability there. And there are a couple of other recommendations to be worked with. One could be that each country had a national aggregator of the data covering the state of the environment as the foundation for all type of things. Another recommendation would be, and that refers also to the work we should talk about here, to really look into the value potential in the interface between data from technical infrastructure and data from the surrounding recipients. Next, which I think is the last one. Yes, my contact information. And as said, I can forward the white paper to Jörg, and you are very welcome to comment. Thanks a lot.
Thank you very much, Hendrik. That was very interesting. I think there are some questions from the audience, but if you have time to follow the entire session, like, then I would probably continue with like our in-depth talk. Like, or if there's anything urgent or like something like referring to a specific detail of what Hendrik mentioned, we could also have a short question now.
I can stay until 1, and as I
Yep.
said, I can circulate the white paper, be available for follow-up talks, and eventually, Jörg, I will be cooperating with some of your colleagues in the urban M2O project starting June 1st, where we will lead the work on the work package on data management. So eventually, I will meet with you or some of your colleagues there.
Good.
And that very much is about urban drainage. So I think there are some things converging here.
Good. Then I motivate like 2-3 questions. And I have plenty on my list, but then I would continue with the talk of Alfredo, and unfortunately, Alfredo can only be here electronically. But we recorded the talk, and I think we can then have like a discussion for the input later. Alfredo, welcome.
Good afternoon, everyone. I'm Alfredo, and I work with Jörg at Eawag, and together we collaborate in the data harmonization of the Co-UDlabs project. And when we began the task of harmonizing data, we need to ask ourselves first, what are we measuring and how are we measuring it? This is because our consortium includes 9 partners from 7 European countries, and each one of them has very unique research facilities. which means that there is a diverse range of variables and methods that we need to put together. I would say there are broadly two groups of data coming in. The data coming from individual lab research, where we have control experiments, and the data from water-oriented living labs, which is a bit more real-world monitoring in urban environments. And as part of the initial work, we started collecting and analyzing the data from the project data management plans. I think this is a good starting point to compare the variables, the sensors, and the units that are being used all over the project. And we group them into categories pretty much to understand the research focus across the Co-UDlabs and how these variables are distributed. And this helps to identify overlaps and to identify gaps and also opportunities for harmonization. And so we need to ask ourselves an important question, and is are we complying with the fair data principles? This is because under the EU Data Act, the data that is generated from publicly funded projects, it must comply with the FAIR principles to maximize the value. What this means is that I mean, our project is not just about generating data; it's also about making sure that this data it's shared, it's understood, and it's also reused. And for this, we look at how different EU countries and organizations are managing water data. And for example, in the UK, we can talk a bit about the Stream Water Data Portal, which is an initiative by water companies to create this platform where water data is available for everyone to access. And it focuses on establishing a data sharing infrastructure, and this data platform is built on the Inspire directive. In France, the urban drainage data management, it's a national level, regional and local. There are also specific systems in place like the ADES, which focuses on groundwater data, and NEIEDES, which focus on surface water quality data. You also have the system Sandre that provides the data models, and a centralized platform, France, for accessing water-related data tools and reports. In Switzerland, we have some frameworks that are developed by the Association of Swiss Wastewater, VSA, like the DSS, the Data Structure Sewer, which is used to document and manage urban drainage infrastructure. As a guideline, there is also like the General Drainage Planning document, which provides an inventory of urban drainage systems at the municipal level. And there is also the Wastewater Treatment Plant Database, ARA-DB, that records information about wastewater treatment plants. Unfortunately, this is not completely fair compliant, as the accessibility is a bit limited to the public due to privacy and security concerns. We also have the case of the Netherlands, where we can see the GWSW project as an example of fair practices. And this is an ontology that provides the concepts for describing systems in urban water management. So it defines the terms and concepts for urban drainage components like sewer pipes and manholes, and it is built on semantic web technologies like the RDF and OWL. which they allow the data to be easily exchanged between systems. And this is widely adopted by the municipalities and companies in the Netherlands. So in this diversity of approaches in the EU, we are definitely seeing the use of many standards. So the idea is not that we reinvent the wheel for something that fits our case, or adding these 15 standards. We should actually aim to adopt the ones that exist already, to make use of them and see how they fit into our needs. And there are standards available for describing and sharing the monitoring of water-related data. We have the Open Geospatial Consortium with standards like the WaterML that facilitates the exchange of hydrological data. We also have the observation and measurements, which provides like a framework for describing observations under metadata. And on the other side, you have the Inspire that ensures the compliance with the EU Spatial Data Directive. From the World Wide Web Consortium, you have the Semantic Sensor Network Ontology, SSN, which is a broader ontology for describing sensors and observations. While the Sensor Observation Sample and Actuator, which is the SOSA, is a bit more focused on practical applications within the SSN. What is important to notice this is that each standard, even though it serves like a specific purpose, they're actually all interconnected in different ways. For example, the WaterML is another specialization of the O&M. Also, Inspire builds on the O&M standard. And similarly, the SOSA and SSN have the observation and measurement concepts into the semantic web. So these standards and ontologies are actually they're not disconnected. They share these foundational concepts, and they're even developed by overlapping communities. So they are quite interoperable between each other. If we go a bit further down into the OGC standard, there are many standards that developed by the OGC. They can be the type of information models, which defines the data structures and relationships. For example, how observations are represented, or how the sensor metadata is structured. You also have the service models that focus a bit more on how the data structure are accessed and shared via web services. And for the information models, so the hydrology community has made progress through the WaterML standard. Now there is the WaterML 2.0, which is currently undergoing some updates to meet the needs in the water data management field. And this is being updated based on the findings from this water quality interoperability experiment, which is ongoing at the moment. So there was a need for a best practice document to guide this implementation of the WaterML 2.0 water quality. Now the question that we need to ask here is the urban drainage field one of these use cases of the water quality within the OGC? Like, is this is something that we need to analyze if our case can be part of the cases from the water quality model. And for the service model, you have the SensorThings API, which is an open standard to manage and share data collected from sensors. What make interesting this standard is the functionality for managing observation. The data can be accessed using the standard HTTP methods. The sensor things API aligns with the observation and measurements model, the 1M model, and also integrates with the WaterML standard. And what you can see there is that the data model of the sensor things API is a structure around components like the data stream, the sensor things, observation, observed property, and these elements describe the relationships between sensors and the phenomena they measure and the physical objects or environments that are monitored. And here is how a case for the urban drainage system community or field. In this case, this is an observation of flow rate from a flow sensor in this UDS context, or what it will look like within the Sensor Teams API framework. Where you can see that the thing is the sewer pipe section. The sensor is the ultrasonic flow meter. The observed property is the flow rate, and the observation you can see is a result of with its timestamp, and the location is some GPS coordinates. Feature of interest is the water flow in the sewer pipe. And so this is an example of what a use case could look like for the UDS community. On the other hand, we have another tool that is quite important for the promotion and implementation of the FAIR principles is the ontologies, which they provide a structure, vocabulary for key concepts, variables, relationships within the field. We need to focus on reusing the existing frameworks that we have, and these existing standards can provide the structured vocabularies and relationships that can guide to the data interpretation. We also know that building this ontology is quite a lot of effort. It requires a collaborative and iterative process. And to start developing an ontology, we should ask like certain questions like what domain should the ontology cover, and the limits of this domain, and also like how can it support the data harmonization efforts? What type of questions should the ontology answer, particularly in relation to monitoring system, infrastructure, variables, some sort of this, like this, and then who will use and maintain the ontology to keep it kind of relevant over time. And as part of an effort to understand what resources we have related to ontologies in the urban drainage field, we make use of the GWSW, the Dutch ontology that I was talking about. We translated this into English, and we also map the Co-UDlabs project variables to the ontology to identify the utility and limitations of it. And even though it offers a very strong foundation, particularly for operational wastewater system, it falls a bit short on the needs of research lab data to meet the needs of scientific research in the urban drainage system. We need a bit of a more tailored ontology. Lastly, as we are about to discuss the FAIR data management in the field, I think it's important to also look at what other fields are doing, kind of like an inspiration. So there is this platform that I would recommend to navigate that is called the Materials Cloud, which is, I would say, it's a good role for the FAIR data practices, which is tailored to a specific type of data and users. But this Materials Cloud is designed for FAIR data sharing in computational material science. but its principles and the community collaboration that they're doing, I would say this is quite an inspiration for how fair data practices could be applied to our field. So thank you very much, and let's go into the discussion.
So I would open up the floor for discussion. And these are questions we put up like to motivate if you said, how do I formulate this, right? So it ranges from metadata to who should be in charge of doing this, right? And as a moderator, I would probably continue with this. Like if I ask Henrik, like we have these two things, right? The scientific and the real world data, I would say. And for the scientific data sharing, we have this very nice example of the materials cloud. And when I talked to the creators of this cloud, they said they were lucky, or their best thing they could do is get together after a conference and develop a API. That's what they told me. And maybe you can comment on that, right? Like first, like scientific and like environmental institution data sharing, and then like what specific steps are needed. You mentioned the chemical domain.
Okay, several questions in one. Let me start with on one hand, it's I mean it was a bit difficult because of the sound, etc., to really fully grasp the project and its results, and I really hope that that slide deck can be sent afterwards. I have also several technical people I would like to share it with, also to have that part up against the white paper work. And secondly, especially for data sharing, I would say at this technical level, I'm quite certain my colleague from Waterfall, Sylvain Grelet, would be happy to dive more into matters. Of the two of us, he's the technical guy. I'm basically the marketing agent or whatever you would call it. But it is impressive with this work. I would really like to see it going hand in hand with a vision for an optimal setup. And with that, I think that managing data at the end of the day lies best with a national aggregator, which are able to manage, organize data, and also to facilitate dialogue and eventually outline standards, etc. Because we see so many cross-sector purposes. Right now we're talking about urban drainage, but tomorrow it's another problem. And so designing a system up against a specific problem, I would be concerned that will lead to sub-optimization. We need to design a system which is one data ecosystem encompassing all type of problems. So that is one thing, and that also means, despite researchers doing a good job, I don't see researchers are at the end of the day the ones to really make the design. And to be a bit straightforward, researchers have other needs. They have other wishes for data. And if I put it really black and white and provoking, researchers tend to collect more data than is necessary for the use of the authorities. Eventually, at the end of the day, the authorities are the one paying for the national aggregator. So researchers will have to find a way not to expect the 110% perfect wish list as fully integrated of a national data ecosystem. There are some common things which goes across, and then there are some more specific things which are eventually collected by researchers and shared. And here the question of the APIs come into the picture. Because APIs to me resembles that the stakeholders have a certain level of IT capacity. And we eventually, to be a bit rude again, I don't think we can design a system which is designed to meet all type of IT capacity levels. This has to be for players who can eventually develop, design, manage an API and work with that and have the capacity. In the waterfall discussions, I've come across certain research units who have talked about they were lacking IT capacity, but then I started asking, well, they were operating in so small units that they wouldn't have that capacity with them. So eventually, I think there's an element of being data-driven requires certain IT capacity. It requires organizations of a certain scale. So to be a player in this one. And I think that it means that we will see the possibilities due to hardware capacity, due to AI options, due to the need for having the data ecosystem resembling the physical ecosystem. We will see a need that data sets eventually will have to be equally large. It can't be small pieces of a river, small pieces of an urban area. It has to be, at the end of the day, it has to be data-driven solutions of the end users covering what resembles the physical ecosystem, because we want our solutions to ensure that whatever we're doing is whatever type of value we want to harness. It can't be it can't be at the cost of the environment. We see that pattern in decision support tools now required by our government, at least. Maybe not tomorrow for all countries, but day after tomorrow. Governments will want data-driven, ecosystem scale solutions, which means harnessing some type of value to society without destroying the environment further. Overflows are a fantastic example of this. Overflows are, as I was mentioned, and I think overflows eventually mean that you have to manage against not the number of overflows, not the volume of overflows, but the impact of nutrients to the water recipients, where it causes eutrophication. And that means you eventually have to be able to manage all the monitoring stations where you are dealing with handling your overflow, pumping it, whatever, and then be able to navigate which of these has the largest relative impact up against the ecosystem it's impacting. And that again, I call for this interface recipient thing. But
Yes.
And final answer, recipients will be part of quite a lot of tools we will look into, quite a lot of research work. At the end of the day, the data systems, the data model, the decisions on interoperability starts with how recipients' data are managed. It's not how utility data is managed. That will not be the way it's going. It will be the recipients. And that, again, I would like to see resemble also in this type of work.
Good, thank you. So you were calling for industry, right, to step up, develop solutions, and then using standards which are already there. There are industry, like people in the group. So maybe you could say, what are the biggest barriers from your point of view that we have against the fair adoption?
In our case,
I was calling like for some industry, like for example, Harald, from your perspective, if you could say something, comment on what Hendrik mentioned.
Yeah, I'm thinking what to say. I missed a little bit what in the presentation. I not missed, but perhaps I haven't seen it. What IKT states at as the German position or the German status at the moment. I think where to start. We have to see what do we want to see at the end. If I look at authorities in Germany, they are so diverse. They have different standards. They have different software because it's where they are collecting data, responsible for things. So what do we want to see, and who is collecting data for that, and probably who can make some sort of API or a standard where data is valuable for the public, can be made accessible through an API, and then for a common purpose visible or usable.
Yes. I think like what
So-
Henrik is calling for, something that creates value, right? Like
it creates what is the value we want to have?
you have a
What is the
web
purpose?
service, right? Like where you can upload your sewer system topology, and then it shows you which of the pipes are lying in the groundwater, for example,
Yeah.
right? Because it pulls groundwater data from somewhere else, right? And you don't have to develop this in your engineering company, but then you pay €5 and you can have this service like totally scalable, right? Integrated.
Yeah.
Uh,
Yeah.
what's
remember
needed to
Yeah,
get
yeah.
there?
I'm not so much technical in the OGC standard anymore. We used this OGC standard 10, 15 years ago, but it was for our purposes for overflow, predictive modeling was too slow and not handsome in a way. So that's why we skipped, and we have another system which is proprietary. Of course, that's a problem. But yeah, developed in the last year, so it's quicker on different purposes. Okay, it has also some edges to drive around, but the thing would be if we would set up things like that, and how can we make it available to if we have a customer from this like an authority, how can they make it available to others?
Yes.
So this sort of API. We have something like an API or a part of the software which is called monitoring client. So it's dealing with data coming in and going out, which is adaptable, of course. And on this point, there could be something implemented. But like I said, a lot of data is collected. It's on different ways collected, different time steps, different values. Yeah, you have to see the metadata has to be transported, of course, so it can be made usable in one front end web base or not, however. But I think it's very diverse, and I know we last 1.5 years ago, or let's say not last year, 23, we applied for a system here in Berlin, and but there's a system now set up from the authority, but on the other hand, Berlin Water is doing something else, so they are not talking with each other, and this makes it a little bit difficult. We have so many stakeholders who are collecting data. I talked to a friend who is working in Schleswig-Holstein in the government of the Federal Republic of Friedrichsholstein, this federal state of Friedrichsholstein, and he said every Landkreis, what is it in English? Every not a municipality, but the area you live in, they have the right to develop to use own software, which they buy somewhere, and this is a very complex to unify that. He has to work on the unification of the data, and this is a very complex thing. In a federal state like here, we have the problem of unification and who is setting the standard, and going top down is not wished, not on the wish list.
Mm-hmm. Very good. Thanks for your statement. I look at the time. Are there other comments from the audience? Maybe in the direction of using ontologies as a starting point? Because Hendrik mentioned that the chemicals field. Oh, yeah, there's one contribution from Luis de Souza.
Yeah, thank you, Jörg. This has been quite an interesting discussion. Let me say that I've been involved in water information systems now for more than 20 years. So even before the Inspire Directive was set up. And I must say that in this 20 odd years, a lot has changed. And it was Hendrik that was referring to this need for, let's say, computer science capacity, information systems capacity. And what has happened in the, let's say, last 7-8 years is that the new standards from the OGC, the W3C from ISO, they have substantially reduced that need. So we are getting closer and closer to a paradigm where the experts, not only the experts, but the stakeholders, the people that produce and provide data, can focus more and more on semantics questions, on the kind of questions that we see here on the screen. What kind of ontologies should I use? How can I be fair? How can standards be maintained? These are very important questions. And these stakeholders, they need less and less to worry about the technology itself. And we saw in the presentation earlier, this reference to the Essential Things API. That was a landmark moment in terms of standard setting. It was the first REST API specified by the OGC. And after that, we had more APIs of the genre and a new version of the observations and measurements standard. And now this new version is coming of SOSA and SSM. So the standards that mirror observations and measurements to the semantic web. So this means that at present, the questions are pretty much focused on the domain itself. So like this very interesting question. So in the Netherlands, we have this semantic web ontology developed. It's useful, but it was all in Dutch. So, but we can easily translate that into English or to other languages if needed. It's not enough. It needs to be expanded because it doesn't consider lab measurements very well. And those are the kind of questions that a community like this needs to worry for the moment. I think from the basic computer science, the kind of services, the kind of data structures necessary to get this up and running, there is less and less work to do on that realm. Mm-hmm. So you can really leave that aside to the computer scientists, or even to the people working here within the OGC especially, and W3C in that sense, and really focus on this. There would be a lot I could say about this, but I think these ideas of reusing, of somehow bringing together these scattered initiatives that we see, that especially here in Europe, where pretty much every member state is left to its own devices, defining which kind of properties they want to report or observe to fulfill things such as the Inspire Directive. I think that would be an essential step. I can, in the last minute that we have, just make reference to an interesting resource from the FAO. So the FAO doesn't work on water, it works on agriculture and soil. The FAO has a very interesting project called AgroVoc, which is a large dictionary of concepts and definitions for their own realm that is translated into 19 languages. And that works as kind of an aggregator, like a common point of connection to anyone that wants to publish or wants to gather data on that domain. And maybe there's something like that that can evolve within this project.
Mhm.
And yeah, I can end
Thanks,
on that
Luis.
note.
That's really good. So if you could put this thing in the chat, or like we distribute it to the participants later, that would be nice. Hendrik raised his hand.
Yes, thank you. First of all, thanks for an interesting discussion. I have to leave in a short while. I fully agree with Louis that the work with the standards have come quite a way, and they are converging continuously. Now we need to have those who can make the decisions to actually get it, because we still see, despite good work on standards, the effect is not as we could wish. So it doesn't really spread very fast. It's still a bit preaching to the choir, to put it a bit rude again. So we need a dialogue where we present the value potential and the problems to much higher levels in a non-technical language. That's the thing right now.
Mhm.
So sorry, I have to leave you for another meeting. It's been a pleasure. I have sent the white paper to Jörg for furthering. Please comment. Thanks a lot.
Thanks, Hendrik. So yes, if I look at the time, I think we had a good starting point. Like if we come back to the goals of this meeting, right? If this is somehow remotely interesting to you, reserve some time. We were thinking of like meeting every once a month or like every second month. And we would probably like to develop something for the Urban Drainage Modeling Conference where we could present some results, either from reviewing the Dutch ontology or from like presenting some use cases of value creation, right? Or like maybe even showcasing a demo implementation of this new sensor thing, which we are very close to have. So if that is interesting to you, send me an email or send an email to Alfredo. You could also send an email to the Co-UDlabs project or the International Working Group on Data and Models. And on the one hand, we would like to get the different standards on the table. And I would also like to mention again the project of João Leitão, who is interested in collecting output from flood models. So we could build a large scale flood map archive. If that is interesting to you, get in touch. And yes, then let's see where this is going. Thanks a lot. And we hope to see you in a couple of weeks. Goodbye, everybody.
Goodbye.
Bye.